Picture this. You're sitting in the exam hall. The invigilator announces you have exactly 15 minutes left. The clock is ticking down relentlessly, and you flip the page to find a massive 15-mark coordinate geometry question staring right back at you. Welcome to This Explainer. I'm your host, and today we're decoding the exact strategies Cambridge examiners are looking for in AS and A-level mathematics. We're treating this just like a breaking news story in a fast-paced newsroom. You're under intense deadline pressure. You need to break down the complex story, which is your exam question, and you need to deliver the absolute perfect headline, your final answer. We are specifically tackling that pressure cooker environment of the exam room, focusing primarily on syllabus 9709, but frankly, these strategies are just as vital if you're navigating the 0580, 0606, 4024, 4037, or 4040 syllabuses. We're looking at the foundational topic that appears in literally every single examination series: coordinate geometry and circle equations. Let me introduce you to the core challenge we see every year. Imagine the clock is ticking, and we typically see two distinct approaches from candidates. First, there's Alex. Now, Alex overloads his answers with raw mathematical facts and formulas. He just throws everything he's memorized at the page, but there's absolutely zero structural analysis. Then there's Sam. Sam gets overwhelmed by the time pressure, rushes through the problem, and completely misses the specific command word requirements of the question. He's answering the question he wishes was there, not the one that actually is. Both of these approaches leave incredibly valuable points on the table, resulting in answers covered in red pen marks. Today we are going to fix that, transform those red marks into green check marks, and build your perfect examiner-proof strategy.
Okay, let's dive right into what actually separates average scores from those top-tier elite results. We're going straight to the source. The principal examiner reports explicitly state, and I quote, "Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts." Think about what that really means for a second. This is exactly where our typical approaches from Alex and Sam go completely wrong. Alex lacked the conceptual connection. He was just reciting facts hoping something would stick. Sam couldn't transfer his knowledge because he ignored the actual context of the question in his rush to the finish line. To absolutely ace the rigorous 9709 syllabus, you cannot just rely on rote memorization. It simply won't work. You must understand the underlying fundamental architecture of the mathematics so you can apply it when the examiners throw a curveball at you.
To get you there, we're going to break down this explainer into 4 systematic sections. First, the equation architecture. Second, securing method marks. Third, a deconstruct, solve, and evaluate framework. And finally, the top 3 examiner warnings.
Let's kick things off with Section 1, the equation architecture.
Right, let's look at the bedrock of this entire topic. This core equation, x minus a all squared plus y minus b all squared equals r squared, it's not just a random string of letters. It represents highly precise mathematical definitions and causal relationships. It's essentially Pythagoras' theorem applied to a coordinate grid. The variables a and b dictate the exact non-negotiable center of the circle, while r represents the radius. Every time you see a circle on a graph, this is its DNA. But here is the thing. Top candidates go way further than just knowing the DNA. They recognize exactly how this formula connects to other seemingly unrelated topics. For instance, they intuitively know how to take a linear equation, like y equals mx plus c, and substitute it directly into this circular DNA to solve for the exact, precise points of intersection. They're bridging the gap between straight lines and curves. It's exactly this depth of structural understanding that elevates your grade from a B to an A star.
And this slide brilliantly illustrates our ultimate academic benchmark. The Cambridge framework heavily prioritizes analytical depth and cross-topic integration over just superficial breadth. An average candidate might correctly identify the radius, good for them, but they completely fail to see how the circle equation interacts dynamically with an intersecting line. The top candidate, however, sees the entire board like a chess grandmaster. They recognize that solving those equations simultaneously requires logical, highly structured reasoning. You aren't just doing algebra to find x, you are proving a complex geometric relationship. Top candidates instinctively apply what we can call a PEAL framework to their math. Point, evidence, explanation, link. The point is identifying the geometric rule. The evidence is your raw algebra. The explanation is your step-by-step working. And the link ties your final value back to the specific command word in the question. It's brilliant. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, securing method marks. Listen closely, because this is the exact moment where we transform those painful red pen marks into beautiful green check marks. If you want to maximize your grade potential, you have to internalize this one fact. Examiners heavily reward the process. Your technical methodology on the page is just as important, sometimes more important, than the final numerical answer. Examiners are quite literally desperate to give you points. If you make a silly minor arithmetic error early on, maybe you drop a negative sign under deadline pressure, but you carry that error forward using the absolutely correct analytical framework, you can still secure the vast majority of the method marks for that entire 15-mark question. That's huge. But, and this is a massive but, you can only get those life-saving marks if your logic is visible, crystal clear, and perfectly structured on the page. If it's a messy brain dump, you get nothing.
So, how do we guarantee those method marks? You must rely on a standardized bulletproof sequence for systematic processing. It's a 5-step blueprint. Step 1. Identify key elements. Extract the raw data, like the coordinates and the radius, straight from the text. Step 2. Apply relevant principles. Select your exact circle formula. Step 3. Execute your analysis. This means clear step-by-step substitution and algebraic working, no skipping steps. Step 4. Verify your results to ensure they actually make geometric sense. Does a negative radius make sense? No. Step 5. Present your final answer in the exact format requested. If our hypothetical students Alex and Sam used this exact blueprint, the transformation would be incredible. Alex would stop overloading his paper with irrelevant facts and just cleanly list the identified elements. Sam would stop rushing, breathe, and apply the exact format the command word demanded, totally nailing the headline of the story. Now pause for a second, stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's ramp it up with Section 3. Deconstruct, solve, and evaluate.
I want you to treat this next part like an interactive workshop. Imagine a complex data source or a massive graph is sitting in front of you. You have a 60-second mental timer. Go. When facing a dense exam question, you need to quickly scan and extract the relevant data and attack it using a rigorous 3-part framework. Deconstruct, solve, and evaluate. Let's do a Find the Flaw challenge. Imagine you are the examiner grading a paper, and a student simply wrote down one sentence. The circle intersects the line at coordinates 4, 5, period. Nothing else. What is the fundamental flaw there? Why are they losing almost every mark? The massive flaw is that absolutely no logical steps are shown. They just gave the headline without breaking down the story. To get full marks, you must deconstruct the problem on paper. You have to physically show the substitution of the linear equation into the circle equation. You have to explicitly show the expansion of the quadratic brackets. And you must show the factorization to prove exactly, beyond a shadow of a doubt, how you arrived at those coordinates.
This brings us to a crucial concept: evaluative thinking. Top candidates stand out because they show this higher-order thinking. But remember, in advanced mathematics, evaluative thinking doesn't mean writing an essay about your feelings. It means backing up your claims with hard, indisputable algebraic evidence. Think of it as a speed writing challenge where your math is the vocabulary. If a question asks you to evaluate the precise relationship between a line and a circle, you cannot just write a descriptive guessing paragraph. You need to calculate the discriminant, b squared minus 4ac, of your substituted quadratic equation. That single, precise, beautiful calculation provides the absolute, indisputable evidence you need to justify whether that line is a tangent touching at one point, a secant slicing through 2 points, or if it misses the circle entirely. That is how you use evidence to justify a decision.
Finally, let's uncover Section 4, the top 3 examiner warnings.
We've covered the core equation architecture, and we've built a critical analysis framework. But even if you understand all of that perfectly, there are hidden traps laid out on the exam paper designed to catch thousands of unsuspecting students off guard. So, ask yourself, where do students actually lose the most marks? You might assume the most marks are lost in the incredibly complex algebra, or messing up completing the square, or dealing with some nightmare fractional radii. But the principal examiner reports tell a very different story. The truth is shocking. Marks actually hemorrhage in the fundamental execution of the exam strategy itself, not the hardcore math.
Let's look at the data. The top 3 mistakes are overwhelmingly rooted in basic logic, simple formatting, and reading the context. Mistake number 1, confusing cause and effect. Students constantly confuse the translation of the circle's center with the dilation of its radius. They mix up which variable does what. Mistake number 2, and this is a heartbreaker, forgetting to check the final format. You might do 10 minutes of brilliant, flawless math, but if the command word explicitly asks for the answer in the expanded form of x squared plus y squared plus fx plus gy plus c equals 0, and you just leave it in the bracketed form, you will lose the final crucial marks. You miss the headline.
Mistake number 3, providing answers that entirely ignore the physical or geometric context of the original question. If the math tells you a radius is -5, but the context is a physical circle, you have to evaluate and reject that negative value.
Furthermore, examiners have issued a major, flashing red alert regarding mathematical conventions. You absolutely must define your terminology and use proper headings in your working. When you are writing out a long geometric proof involving your circle equation, do not use vague pronouns. Do not just say, "it intersects here." What is it? Name the line, name the circle. Say, "line L intersects circle C." Clear annotation is not just there to make the examiner's life easier when reading your work, it actively psychologically clarifies your own thought process in the moment. It completely prevents the exact kind of blind, rushing errors that drain points from otherwise incredibly capable students like Sam.
To ensure you absolutely do not miss these steps when the exam pressure spikes and the clock is counting down, utilize a memory hack using the first letters of our procedural sequence: identify, apply, execute, verify, present. IAEVP. Create a silly phrase that sticks in your mind right now. By rigorously applying this sequence, consistently decoding those tricky command words, and keeping your algebraic steps tightly logically structured, you are systematically unlocking your top mark potential. It's like a cheat code for the exam.
So let's wrap this up with our complete answering system. We have 3 rules that guarantee top marks: command word decoding, applying that Peel framework, and using a time management matrix so you don't panic. As you sit down to review your past papers tonight, I want you to ask yourself this one final critical question. Don't just throw formulas at the wall hoping they stick, and whatever you do, don't rush past the command words. Deconstruct the story they are giving you, solve it with absolute methodical precision, and evaluate your final headline answer. Are you just blindly calculating, or are you strategically building an examiner-proof mathematical argument? Now listen up. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel AC Exams at acexams_IGCE to excel in your Cambridge examinations. Subscribe right now to at acexams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.